Are you able to see my slide?
Yes.
Yes, we can.
Yes.
All right. Good morning, good afternoon, good evening to everyone. Thank you for attending the Exchanging Ideas 14 Global 5G Evolution. And for the viewers, please take a minute to click the subscribe button on our YouTube channel. And welcome to all the great speakers from all parts of the world to come on this occasion and present all related 5G technologies topics. Thank you again. And the title topic that I would like to present today is 5G private networks, transforming enterprise and industry. Now, if you see on this slide, this is particularly focusing on the port terminal, where digital transformation of all industries are coming very quickly, and terminal operations are no exception. Future ports being established to have digital awareness and management of everything passing through them in a real time. So automation and autonomous technologies will find new roles in terminal operations, just as they are being employed in many other areas of the economy. Today, industrial grade wireless solutions like 5G can provide the communication platform for the full digital transformation of terminal operations, from low powered sensors, RF based location based services, to high capacity mobile video remote control cranes and straddle shuttle carriers. And it is possible to support those terminal, not only limiting from a vessel, but also towards to the trucks and or even the trains. If you see this particular slide, this one part that I would like to stress is the digital twins of the terminal operations that has already been applied to some of the world best spots in order to optimize the overall workflow optimizations. Like if you see this, to increase terminal, the TEU means a 20-foot measurement unit throughput that has 7 to 10% of efficiency due to the 5G mission critical communication system, where 5G can able to do a complete control to connect the mobile devices, sensors, and actuators. It is possible to save up to 7 to 10% in the overall efficiency of the operations. Now, this is very interesting slide here, where if you see on the top part of this, a single port terminal may consequently be hosting 5 or even more separate wireless networks, such as a fragmentation of wireless system with simplified with today's 5G that will function on a very much of a converged platform. Everything can be converged together for a mission and business critical voice, data, and video services. Besides mobile broadband, the latest release of a 5G and also the LTE 4.9G, as claimed by Nokia, has also implemented a converged together of a narrowband IoT and LTE-M to support M2M communications, IoT sensors, and other low-powered devices. So each of these use cases has its unique characteristics in terms of coverage, capacity, latency, and also the criticality. So 5G network in a port terminal is deployed in a private manner solely for the use of the terminal operations. It is custom built to meet specific use cases and coverage requirements. Now, this is one area that I would like to stress is all about is that, like terminal operations, they cannot afford to suffer breaks in communications as the container handling machineries moves through the yard and navigates the constantly changing of topography of the container stacks, right? So the degree of mobility is inherent in terminal operations, and the radio reflections that caused by the metal surface of the containers and interference with neighboring wireless network present is a challenge for the Wi-Fi. So in that sense, Wi-Fi can be cannot be the right solution in terms of the reliability and predictability when it comes to port terminals. So I would really recommend that 5G private network would be the best option. This is another particular slide where we see a comparison of a fixed network, the private 5G, and on the right hand side is the Wi-Fi, right? Fortunately, there has been widespread pressure placed on the governments who are responding by freeing up spectrum and use by enterprises in industrial and other applications from healthcare to mining, right? So 5G vendors have developed solutions that use unlicensed or lightly licensed spectrum. Like Nokia, for instance, has also developed enterprise size version of the technology that are no more difficult to install, right, and maintain than a standard LAN or a Wi-Fi network. So this results that terminal operators now have a better choice as they plan for the digital future and can benefit from the technical advantages of a 5G by building out private 5G network covering the container port terminals. So if you see this particular section, 5G can provide Ethernet levels of service in terms of interference handling, reliability, service prioritization, security, and capacity without the need for cabling. And it exceeds the wireless capability of Wi-Fi in terms of coverage, number of active connection per access point, and it supports for a high speed mobility. And also the other area that I would like to stress is 5G has the ability to create slices within the network to securely separate applications and provide specific quality levels or quality controls, the QoS for each application. Like for instance, like the IT department can allocate higher bandwidth for video on one slice, and then the narrowband IoT or LTM for handling low power IoT sensors on another slice, and then perhaps the time sensitive low latency for automated remotely controlled operation in another slice, right? So you can actually prioritize the network slicing in that manner. So that is one of the main advantage of having the private 5G in comparison with the Wi-Fi or Wi-Fi 6. And this is a slide that it gives a comparison between a standalone private network on the left and compared to the right hand side of a public network integrated private network, right, with the help of a mobile network operator. And as you see on the left hand side, these are the key areas that the enterprise need to actually own their license, and they must have their own IT department integration and the connectivity provisioning. They got to be responsible in terms of the SIM and the UE subscriptions. They got to the only issue is there's a lack of roaming because it's an independent network, right? And there's a high capex because they got to build the whole infra. But if they share with the mobile network operators, therefore, in terms of the spectrum and unlicensed, that is taken care by the MNO, and they just need to pay in terms of a monthly managed service of hosting towards the MNO, right? And the MNO will take care of the end-to-end security, and also the regular roaming, everything is taken care by the MNO. So the capex part is lower, but then when there is some sort of higher OPEX in terms of the monthly managed services cost. And this is lastly, what I would like to stress here is this last slide of mine. I'm just trying to show these particular boxes on the left-hand sides are the private network enterprises boxes, and the right-hand side is the MNO. So if it's an independent, dedicated private network, then you are zero dependency on the MNO, and you got to build the core network function, from the 3GPP SA2 with the CN functions, the core network, where a bit of 5GC network functions, like for example, the user plane function that supports the packet routing and forwarding and the packet inspection. Then we have the control plane, and then you got to have the PCF, the policy control functions that needs to be applied. with the control plane, and then you have the unified data management that supports the generation of authentication and key agreement, credentials and access authorization. So the whole the service-based architecture needs to be built. That's a huge capex that's involved when it comes to enterprise, right? So, but if the enterprise wants to use the RAN shared, that means the RAN used by the or implemented by the mobile network operator, obviously the only part they got to invest in is the UPF portion. Or it can be on the network slicing. If it's a network slicing, of course, definitely the enterprise has to be fully dependent from the MNO. So I think due to the time constraint here, this is overall my presentation of the 5G private network. And I would like to pass on to the next speaker. Let me introduce Fred Tuat from Paris, France, to present on the non-voice 5G AR and application developers to be distributed. Over to you, Fred.
Yeah, thank you. Let me just make sure my setup is correct, and I will share my screen. Thank you, everyone. I'm very glad to be here today. Hello to the one I've been already meeting, and very glad to meet. What I'd love to show you today is basically, you see the screen is okay?
Yes.
Yeah. Sorry. Okay. I'd like to introduce you to Non-Voice. Non-Voice is a new agency helping developers in the 5G and augmented reality and the so-called XR, remote reality as well, helping the developers to deploy their apps. So because we've been seeing so many work on the infrastructure side, now we see also tons of developers who are trying to get their work in the hands of the end user, in the B2C as well in the B2B sectors. And therefore, we've been deploying a catalog of apps, considering 4 verticals: sport apps, AR games, which is obviously one of the first sector which will help the end user to understand. But education is also a very strong vertical where we see tons of developers building very interesting apps, as well as you know, enterprise services. I'd love maybe to start with some examples to keep this discussion today as interactive as possible, and to show you what the end user can do thanks to 5G. Let's take, for example, this beautiful Leo AR, where actually dedicated to educations, tons of new experience can be built for kids on their tablets. Therefore, this little video explaining you here exactly the numerous scenarios that can be built, that can be developed for any education purposes for kids. In this very case, you can animate augmented reality characters within existing scenes to involve and better perform in terms of education. Obviously, games will be also a very strong vertical where, for example, you can play with the reality. This is an open-hockey game where actually you just need your phone to play live, nothing more than that. No glasses, no AR devices, just your phone. And this can only be made thanks to the very low latency of the network. I'd love you also to show you tons of sports apps, since stadiums will be a very strong potential, a very big potential for deploying apps, implying the soccer fan, for example, or the sport fan within the arena, in the venue, with an app, is also one strong vertical. And last but not least, we've helped a series of developers in the enterprise vertical to build and deploy their apps within the carriers. This, for example, is Confer, where with Confer you can actually virtually meet someone remotely and in a real 3D chat. We've also selected numerous couponing apps, advertising apps. Basically, all those shows that there is a very high level of creativity at this stage in the end user developer community. We want to help that, and this is the purpose of non-voice. Thank you.
That was very quick, Fred. We have another 5 minutes. Would you mind to present the Womber? If
yeah, sure. That's a good opportunity. So there is one project which is very, let's say, do you see the screen? No, not yet.
Not yet.
Okay, just a second. You see the presentation?
Yes.
Okay. One developer based out of France has been launching, is actually testing and launching a project to help to play with 5G and to make sure that 5G is really at the core of the experience, the end user experience. And why a 5G game? Why a racing game? Basically because latency is magical. And let me show you a very quick video of the experience that the developers want to build. Basically, with Womber, you are able to drive real cars on real tracks in real races against real opponents. Those will be streamed live over the network, and to provide the best user experience with cameras embedded into the cars, streaming live the exact race. This is pretty much it. The project is in infancy. There are actually today and tomorrow tests, live tests, organized by the developer. And this is just the typical definition of a end user B2C, very promising app to be deployed over 5G networks. This is called remote reality. This is a new vertical that we've seen in gaming developing lately. Startups have been raising money to build those games. In this very, very, very simple case of Womber, it's a very basic game. It really helps to understand why is 5G latency so magical. Thank you so much.
Thank you, Fred. I appreciate that. So now I would like to introduce 𝗦𝘂𝗽𝗽𝐺 from Tehran, Iran, to present on the 5G network slicing.
Do you have my screen?
Yes.
Okay. Hello all. I'm pleased and humbled to attend this brainstorming session. I'm 𝗦𝘂𝗽𝗽𝐺. I've been working in telco industry for around 13 years. The vast majority of my experience revolves around mobile core. Today, I will be talking about a key piece of 5G technology that is network slicing. At first, I will start with network slicing definition, and then we will talk about background of network slicing, and it will be followed by network slice management, and we will conclude with network slice selection assistance information. Okay, let's see what is network slicing. Network slicing is to create logical end-to-end network instances which share underlying network and meet particular business requirements. Let's call them service level specifications. Actually, network slicing is shifting paradigm from a static network to isolated logical networks. Which enables operators to get new revenue streams by giving premium services for existing customers and improving their ARPU, and also reaching new customers. Network slicing is being tracked by access point name and dedicated core network, which is introduced in release 13 of throughput, and enhanced core, which is introduced in R14 of throughput. And also we had some attempts for segmentation of the network, like network sharing, MOCN, and even MORAN. Multiple SDOs are working on network slicing architecture and the specifications of the components. NGMN was the first to show the 5G network slicing concept with these three layers of layers of service instance, network slicing instance, sub-network. Actually, this is one extra layer. It is not introduced here, and resource layer. Service instances like known services of URLLC, EMBB, MMTC, and network slices is a network component corresponding to these services. Okay, let's see what are the different kinds of communication services. Services which are offered by communication service providers to communication service customers, which are business to consumer services, for instance, rich communication services, web browsing, or for example, 5G voice. Another type of those services would be considered business to business services. Here we have LAN interconnection and internet access. Another type of service is business to household services. These are services like EMBMS or internet access as well. There are other kind of services of business to everything, like roaming, like WAN sharing. There's another interesting topic here, network slice as a service. It is actually a service which is offered by communication service provider to communication service customer, and those services could be characterized by certain properties. And these are capabilities to satisfy service level agreement. For example, radio access technology, or bandwidth, end-to-end latency, reliability, guaranteed and non-guaranteed QoS, the security level. For example, operator can offer dedicated radio or core resources to different enterprises, and we can call it NSAAS. Here we have network slice instance lifecycle. Lifecycle of one network slice starts with preparation. In preparation phase, there is no network slice available. We are just designing. We have capacity planning and creation and onboarding of network slice templates. All of them are included in this phase. After that, we enter the commissioning phase. In commissioning phase, all needed resources are allocated and configured. Later, there is operation phase. It's an important phase in life cycle of network slice instance, which is activation, modification, and deactivation of network slice. Also, supervision and performance reporting, like KPI monitoring, could be considered here. Whenever the life cycle of one network slice is finished, we have to terminate it. And it is the commissioning phase in life cycle of that network slice instead. Okay, and here, network slice management. Coordinated management is essential between RAN, core, and transport domains to ensure end-to-end SLA. This one will include cross-domain orchestration because some of those entities are managed by 𝗘𝘃cie, some others like, for example, RAN and core, and some others like transport are not managed by 𝗘𝘃cie. And there would be some coordination and orchestration between these domains. As you see here, we have communication service management function. Which handles the life cycle of customer side services. This is like one translator from business side to network side. Under that one, we have NSMF, which is network slice management function. This one manages different network slices and makes orchestration and coordination, cross-domain coordination actually. Under this one, we have network slice subnet management functions for each domain, for access, for core. Monetization and the life cycle, delivery of services, time delivery of services are crucial. And all of these drive demand for automation. Let's see what is network slice selection assistance information. That abbreviation is really hard to pronounce, but it is collection of single NSSAIs. What is SNSSAI? Single network slice selection assistance information. Within a PLMN, you see one network slice is identified by SNSSAI. SNSSAI is composed of SST, a slice service type, and a slice differentiator. This one is 3 bytes, and this one is 1 byte, and this one is 3 bytes. In a standard SNSSAIs, ST doesn't have any value, but we have values for SST. But in operator-defined SNSSAIs, ST also can have different values. You can see here, we have standard SST values. SST value of 1, which is allocated for EMBB. Number 2 is for URLLC, 3 is for MIoT, and 4 is vehicle to everything. And the reason of having these standard SST values is to make the interoperability of slicing between PLMNs during roaming. We have different variations for SNSSAIs. At first, we have subscribed SNSSAI. It is subscribed on UDM, one network function in 5GC, through home carrier, and a user cannot have more than 8 subscribed SNSSAIs in his profile. Requested NSSAI, this is the parameter or identification which UE sends to network upon registration. This one also cannot be more than 8. We have configured NSSAI, which is configured in serving PLMN. Serving PLMN would be either home network, or home PLMN, or visitor PLMN. We have allowed NSSAI. UE sends the request to AMF, and AMF has to have some communications with different network functions like network slice selection function, NSSF, UDM, to make decision and extract the list of allowed and even rejected SNSSAIs and send it back to UE. That's it for me. I just tried to touch on some important remarks about this topic, but of course, there's a lot that goes into each of those fragments if one intends to look at them in depth. Thank you.
Awesome presentation. Thank you, Leila. Thank you so much. Let's move on to the next speaker. Let me introduce Vivek Parma from Washington, D.C., US, to present on 5G and hyperscaling.
Thank you, Ganesh. This is Vivek Parmar, based out of Washington, D.C. And over the years, I've worked in telcos, network equipment manufacturers, and service providers. And it's given me a very good perspective right from the time the 2G network started. But I want to believe and tell myself that I've never been more excited than I have been today for 5G. And as you would see me posting a lot about 5G and talking a lot about 5G on LinkedIn, you would see that there are many things that have been coming up. And today I wanted to kind of talk about how we are kind of, merging the concepts of telcos and hyperscalers together. All right. So let's start the presentation by talking about the agenda. So today I'm just going to cover two major points in my presentation. One is what is the need for hyperscaling within 5G and why are telcos kind of dependent on that? And secondly is the concept of, whether the telcos and hyperscalers, are they kind of friends? Are they on the different side of the equation on the 5G side? So those are the two major concepts that we're going to talk about. Let me start off by talking about a recent example that came in when Belgium's third largest telco announced that the fact that they are kind of going with Google as one of their partners. This was probably the first time that we saw a name from hyperscaling coming into a partnership with the in the telco world. And as some of you may know that, this is the platform that we're talking about is called Google Anthos. And what Telnet is kind of envisioning is a completely cloud native 5G network. Cloud native, as we know, kind of sees all network functions that would traditionally be delivered by a hardware-based system to be run as a software application in the cloud. And this is where the concept of hyperscalers come in, right? So hyperscalers are essentially providers of cloud networking and internet services at scale, and that's where the term scalers comes in by offering organizations what we call as infrastructure as a service. Many times, hyperscalers are also called web scalers in various contexts. The next thing I wanted to talk about was the first point that we discussed, which is 5G and what is the need of hyperscalers. So software, as we see, is permeating into every network layer, and we've seen that standardization bodies try to draft their own cloud architectures. We've seen that 𝗏𝗏ci kind of do some research on that, and 3GPP also kind of working together with 𝗏𝗏ci to come out with standards. But more often than not, I think what we are seeing is that everything, network infrastructure, is increasingly being adopting and moving towards what we call as the web scale architecture. So it's they are trying to kind of imbibe whatever the web scalers or hyperscalers did into their own network architecture. With 5G, cellular networks are moving to a much more distributed compute and distributed core with a completely software managed systems. These cloud companies or hyperscalers have already kind of done a lot of work in this area, and they are masters of it, and they built their networks around that around these concepts. Another aspect of the need for hyperscaler comes from the fact that operators at this stage don't want to be left behind and be just providers of connectivity, right? They want to move up the value chain. And use cases such as edge computing and some of the other private networks that we talked about were brought in and can be brought in via the web scale architecture, right? And what aspects of web scale or hyperscaling architectures we can utilize here? You can think about all the analytics, the management capabilities, the AI ML capabilities that are inherent in these hyperscale or web scale platforms, that the telcos can easily utilize for 5G. The other advantages that possibly that hyperscalers can bring in is OpEx advantages. And why I say that is because the web scaling architecture inherently kind of utilizes a lot of automation features and of course virtualization features, which can kind of bring in these operational efficiencies to the 5G networks. I wanted to spend just a minute on what is the strategy that we are seeing from various hyperscalers in the telecom and 5G space. So, many of us may be familiar with these names, but I wanted to kind of point out 4 major cloud providers and what their strategy is in this space. So AWS, effectively created a very open field when it released Wavelength, some time back. And as a platform that can embed the AWS compute and store at the edge of a mobile network. And I think AWS does deserve some kudos for this because they've been, working to create a complete vertical out of telecom for quite some time. And they were obviously very, one of the first players to on the cloud side to come up with, an offering in the telco space. The AWS Wavelength is unique in many ways that it allows a lot of developers to kind of serve different use cases. I would say, be it ultra low latency, high reliability use cases, or be it utilizing the existing AWS infrastructure for AI ML capabilities at the edge, which serves variety of use cases. And we have already just seen from one of the previous speakers the use cases around augmented reality and virtual reality. So again, they've partnered with a lot of vendors or service providers, I should say, like Verizon and with KDD and SKT on the horizon. It seems like AWS is really making some waves. Microsoft Azure is, the second largest provider of the cloud services, and their strategy more so looks like that they'll be going around and kind of buying different companies and offering a complete end-to-end suite of offerings on the 5G side. So with their acquisitions of a firm on the 𝗰𝗙𝗍 side and a lot of other acquisitions like Metaswitch for network function side, what they are trying to do is come together with their offerings by giving a comprehensive end-to-end suite for multiple services. Google Anthos, we just talked about it. They're making waves with AT&T and then the Belgium operator. And the 4th largest one is IBM, and their strategy seems to be kind of repackaging a lot of their existing components around OpenShift and IBM Edge Application Manager. And another important aspect of things that we saw from IBM was the fact that they were integrating a lot of third-party vendors. And the last count that I saw, they had more than 40 plus pre-integrated vendor setups in their folio to enable that. All this points to the fact that there will be a multi-cloud, multi-carrier strategy, and each one of these big 3 hyperscalers are taking a somewhat unique strategy and approach towards 5G and the edge, and their different services that they're offering are kind of underlying those smaller nuances and differences. The important question that we need to kind of answer is, how do the operators embrace multi-clouds as the cloud providers are embracing multiple carriers on the other side, right? So to me, it seems like the decision ultimately for using one cloud or multiple cloud will be driven by the enterprises in many ways, because enterprises are quite entrenched in the whole hyperscaling business, and they may dictate what they can offer and to whom they want to partner with. And it's a very low risk strategy for cloud providers, at least, because on the enterprise side, they're already queued into a lot of these enterprises. And for them, it's just another vertical that they can get in using their existing infrastructure. But for the telcos and carriers, I think this is a completely new ball game, and they have to play their game right. So that gets me to the last part of my presentation, where I wanted to kind of talk about whether the telcos and the hyperscalers are friends or foes. Are they on the same side of the equation? Are they complementary, or are they kind of fighting for the same pie? I think if we were to ask this question a couple of years back, most would say that telcos see hyperscalers as eating their lunch, but most of the operators that we are going to see now are going to rely on hyperscalers in one way or the other, because they've now realized that, and they've kind of resigned to the fact that for the edge and core 5G functions, a public cloud provider or a hyperscaler will be inevitable for them. It just does not make sense for them to kind of invest in their own cloud infrastructure at this moment. Of course, given the need that it is prohibitively expensive to kind of build such a private cloud, hence the fact that they would need to kind of collaborate with them. I kind of alluded to the fact that telcos don't want to be called just providers of connectivity. They were pipe dreams that they had, and now which is turning to nightmares, in the sense that they want to kind of move up the value chain and not just provide connectivity. And for providing those value-added services, they would need to kind of utilize the inherent capabilities of a hyperscaling network to provide that. So what do they bring? And one more aspect, before I move on to what they bring to the table, was the fact that one of the reasons that the telcos see the hyperscalers as a threat is the fact that hyperscalers have the potential to offer network as a service. In fact, even at this moment, you can buy network as a service from Amazon and from Microsoft. It's kind of limited, but at the same time, I would say you can buy a standard off-the-shelf radio to set up your own private network, use network as a service from Amazon, and set up your own private, cellular network. So, that's one of the reasons that the threat is very real. In the end, I'd like to just say that, each provider, telco as well as the hyperscaler, brings something to the table. So with telcos providing and having strong experience on connectivity and networking, and hyperscalers bringing in scale, agility, their whole software background, innovation, AI, ML, the inherent capabilities that they bring, a win-win can only happen when both parties play to their strengths, and it enables them to deliver the best possible value to the end user, which in this case may be an end user or an enterprise. So that's it from my side. Just a parting note on the partnerships that we are seeing. Different providers around the world are kind of partnering with different operators are kind of partnering with different cloud service platforms and web scalers. Here is a small list for everyone's reference. That's it from my side. Thanks, everyone.
Excellent articulation. Thank you, Vivek. Thank you so much for your time. I appreciate that. Let's move on to the next speaker. Lawrence Duke from Brisbane, Australia, to present 5G private network in mining. Over to you, Lawrence.
Thanks, Ganesh. Can you see my screen now?
Yes.
Okay. So Ganesh introduced, I'm Lawrence. I'm based in Brisbane, Australia. My background is I've worked for mobile network operators before I joined the mining industry in Australia. So because of the need for connectivity at mine sites, most big Australian companies have been sort of like recruiting people of a telco background, which is something that no one maybe would have predicted, I don't know, 10, 15 years ago. But now there's this new stage whereby they've realized the need to have connectivity. So at the moment, I'm working for Hitachi Construction Machinery, which is an OEM that manufactures construction and earth-moving equipment. And I am supporting a division which does autonomous haulage system. So basically what we are doing is we are trying to replace humans by onboard controllers, such that we have a truck that is being controlled by onboard controllers and sensors to try and create more value for the mines. So I will start my presentation. So I came across this quote when I was just researching on this presentation, that what is modern mining? So modern mining is about moving tons of earth to extract economic ores, but beneath the surface, modern mining is efficient mining, which is a more carefully choreographed ballet in which fleets of multi-million-dollar high-tech vehicles and equipment are dispatched, managed, and monitored using sophisticated hardware and software running over advanced broadband networks. The terrestrial shovel and drill are guided by GPS satellites orbiting miles above. It's where the dump truck meets the data center. The shovel or truck and drag line are all integrated with voice, video, data networking on a 24/7, 365 basis to optimize mine efficiency, production, and safety. So basically what it's saying there is mining is evolved over the years from simply being an environment where people are digging dirt to extract valuable ores beneath the Earth's surface, but it's now a high-tech environment where a lot of machines are automated, and the drive for it, I think I will explain in this slide. So what is exactly driving this need for automation in mining? The first thing is safety. So mines traditionally have a poor record when it comes to safety, because it's quite a dangerous environment. There are big machines, and often mine pits they are just these big holes that people dig up, and we also have underground mining. So it often puts humans in harm's way. So automation will allow mines to be able to remove humans with robots, such that some of the dangerous places where we required a human to be operating a machine, and in our case, someone had to drive a dump truck from the loading bay to the dumping bay, and the typical mine operator does a 12-hour shift, and they are just given, I think, 4 creep breaks that are 30 minutes long. So imagine the fatigue of that operator who has to do a 12-hour shift, just doing the same routine. You go to the loading, the truck is loaded, you drive to the dumping bay, and you have to do that for 12 hours a day. In underground mines as well, people often are exposed to dangerous conditions when they have to go underground. But all that is being sort of like changed by embracing 5G or LTE in mining. So how does 5G or LTE in mining help to improve or enhance safety? So as the first slide pointed out, the first thing that I would mention, it facilitates the ability to replace humans with robots or machines. So instead of having a human being, we'll have a machine, but that machine, we should be able to remotely control and monitor all the sensors and send commands to actuators on the machine so that it can perform a certain desired action. So it brings the need for high reliable and fast networks. Hence, we see the rise in popularity of 5G and LTE in mining. And then the other thing that's driving the popularity and adoption of 5G and LTE in Australian mines is labor costs. So in Australia, we are home to some of the world's biggest mines. And unfortunately, they are located in the remote sides of Australia. Some of the biggest iron ore mines are in the Pilbara, which is a very, it's not a very good place for humans. So to lure people to leave the comfort of the cities and go and operate machines on a mine site, mining companies tend to pay very high wages for that. And it's really a major cost that mining companies are trying to sort of like reduce by embracing automation. So instead of having an operator driving your dump truck on 12-hour shifts who is susceptible to fatigue, sometimes you can have unplanned absenteeism, someone who just decide to not show up, and also we have got a lot of high staff turnover because it's not really a nice or ideal environment to work in. So in order to address that challenge, mines are having to automate, and with the automation, there is the need to have reliable, low latency networks that can facilitate the automation of the dump truck. So, and 5G is also giving them the ability to reduce their labor cost by replacing operators with automated dump trucks. The other thing is quality of service, network slicing, and virtualization. The previous speakers did a good job to explain what these terms are when it comes to 5G or LTE. However, I'll try to tie it down and give a practical sort of like scenario on how this benefits a mining operation. So currently at a mine site, you typically have multiple networks that support different applications. For example, for mission critical voice, mines usually, actually, it's sort of like the de facto standard at the moment is your digital radio systems, which is P25, which is a US standard, and Tetra, which is more European. So that's the go-to technology when it comes to two-way radio. So it needs its own hardware, it needs its own trailers and base stations, power, and everything that comes with hardware to support such a network. And then on top of that, they have a separate network, which is its own underlying hardware to carry their data traffic. And then by data traffic, I mean their video, their fleet management systems, or their autonomous haulage systems, and every other thing that needs communication maybe between their application servers and machines that are in the field. So in that scenario, you get multiple networks that can be replaced by one unified network. And the previous speakers explained how quality of service network slicing can be leveraged in an environment whereby you can allocate a certain type of traffic, a certain slice, or a certain logical resource of the network, but all of the traffic will be using the same or sharing the same underlying hardware. So this is a very big step when it comes to mining, is it to minimize the amount of hardware that they have to administer. They'll be able to save on power. And a mining environment is a challenging one because it's very dynamic. So most of our networks are deployed using trailers. So we have to mount an E-Node B on a trailer. Often we have to put solar batteries because at one point you have line of sight, but then there's a dump growing, and before you know it, in a couple of weeks, you lose line of sight. You have to redo your coverage predictions and move the trailers. So it needs a technology whereby you can be able to move your run plant. But if you can have maybe virtualization whereby you have your virtualized 𝗦𝗙𝐶 or virtualized 5G core, you only have to deal with the problem of moving the radio access network equipment, but the virtualized part of the network, which is the core, it's residing somewhere in a cloud, and you don't really have to bother in moving it. Unlike a situation where you have got a local core, which has got hardware, and then you are told by the mine planner that our iron ore seam is passing through where your temporary data center is, so they will need you to move it. It becomes a challenge. So quality of service, network slicing, and virtualization are definitely drivers that are advantageous to the adopter when it comes to adoption of 5G in mining. So this graphic, I just tried to, forgive me, it's a bit busy, but I tried to just put everything in one sort of like graphic to try and explain what an autonomous haulage system looks like at a typical mine site. So as you can see, we have the control room in the data center. That's where usually you have your controllers with monitors. They have visibility of every machine which is operating in the pit. So for these guys in the control room to be able to monitor what's happening in the pit, they obviously need a reliable wireless broadband network. And that's where you see 5G and LTE as a use case. So the guy seated in the control room needs to know exactly where each dump truck is, where the route in which it's driving, which machine it's interacting with, and also all the sensor data that's on all these machines. They are consistently pumping a lot of traffic in the uplink. So one challenge that we're having with LTE is more, has more capacity on the downlink than on the uplink. But in a mining setup, you have got more traffic on the uplink than on the downlink, because you've got a lot of sensors that are consistently pumping traffic on the uplink towards the control room. So 5G, I think, with its gigabit per second throughput will go a long way in sort of like alleviating that bottleneck. So here we have a dump truck. Typically, a dump truck will have a GPS antenna receiver. So the GPS, its purpose is it receives location information from satellites that are orbiting. And then there's also a GNSS base station that also receives GPS signals from orbiting antenna. And then that GNSS base station, it has to send correction signal to all machines that are operating in the pit, such that those machines can compete, can actually compare what they are receiving directly and what's coming from the high precision GNSS base station. That way we can be able to achieve positioning accuracy of within meters. And then on the same track, you have usually a 5G UE or LTE UE. So that UE now is the one that enables the dump truck to be able to connect to the LTE or 5G network and give it a network that will connect this dump truck and all on-board systems to the application servers that are usually in the data center here. So also in this diagram, I omitted putting the virtualized 𝗵𝚻 core, but the virtualized 𝗵𝚻 will be seated also in the data center here, and the dump trucks or any other machine that is in the pit has to communicate via the G node B or E node B through the 𝗵𝚻 to access the application servers. And then on top of that, you have got sensors. So these things, to those of you who have been to a mine site, these are very, very big machines. It's like a small house on wheels. So these things are literally, they have got sensors all over the body of this thing to try and give us the best sort of like perception of how this massive beast of a machine is performing. So on autonomous haulage trucks, the most popular sensor as of now is LiDAR, which is light detection and ranging. And then you also have millimeter wave radar, and you have got your normal camera, which is video footage. So all these sensors are gathering information, sending to the onboard controller, which is connected to your 5G UE or LTE UE, that then transmits all that information back to application servers in your control room. So you can see that there's a lot of sensors that are pumping data so that we can have a clear perception of what's happening in the pit. And also we have got these automated vehicles, they interact with manned instrumented vehicles. Like here you can see there's a wheel dozer, there's a track dozer, and you can also have the digger or excavator. So this truck here, which is an automated truck, will reverse, and then the operator of the digger here will load it, and then he needs a way to give instructions to this truck. After he has finished loading this truck, he has to instruct it to leave the loading bay such that another truck can come and also be filled. So this whole system is supported via a fleet management system. And for this operator or manned instrumented vehicle guy to be able to successfully interact with these automated vehicles in a safe manner in the pit, because there is a lot of vehicles here, and all of them, they really need to have high reliable communication, or 99.99% availability, because the system is designed to tolerate very, very short periods of communication blackouts. So all these processes and systems and all these vehicles interacting with each other, they need a network that has got high availability, high throughput, and low latency. And also the sensors need a lot of capacity to be able to pump all the data they are gathering into from the pit to the control center. So I'll just give a brief overview of what autonomous haulage system or the technology overview. So
excuse me, Lawrence, you have 1 minute to wrap up.
Yeah. So in autonomous system, here's autonomous haulage trucks, which are just self-driving vehicles that drive from one point to another without guidance or assistance. They follow a digital model that's generated by a map builder in the control room, who needs a network to push that digital model to all trucks that are operating so that they can interact safely in the autonomous area zone. And then why automating over humans? As I said, machines, they are not susceptible to fatigue, but we then have to rely on sensors instead of the 5 human senses, because a driver has to rely on his human senses to be able to operate the machine. But on an automated truck, it's now sensors and the onboard controllers. So this is just a graphic showing a truck detecting an obstacle and it being able to avoid it. So it needs a low latency network that can be able to convey obstacle detection on time so that it can take evasive action. This is just a logical diagram showing how everything is interconnected. And lastly, these are use cases of the mines that have autonomous haulage system in productivity in Australia. So it's mostly the OEMs like Komatsu, Hitachi, Caterpillar, Scania, and Volvo, who are in partnership with vendors like Ericsson, Nokia, and Huawei to deliver private 5G and LTE networks. Thank you so much.
Brilliant explanation. I appreciate that. Thank you so much, Lawrence. Moving on to the next speaker. Let me introduce Kwangsun Ko from Seoul, South Korea, to present on 5G Edge and Cloud.
Yeah. At first, nice to meet you. Nice to meet you all of the participants. And let me introduce myself before the presenting. I'm working at the telecommunication company in the South Korea, and as the farmer said, I'm working at some kind of the first telecommunication company in South Korea. So we are working with the AWS wavelengths. Yeah, and I will introduce the 5G mobile edge computing. It's totally related to the network slicing, and also as the presenter said, the hyperscaler yeah. Then also we are co-working with the hyperscaler. So it's pretty related to the previous topic and agenda. So let's start. So in South Korea, we are actually released the 5G NSA 2 or 3 years ago, based on the 5G NSA and 3.5 gigahertz bit. So after that, we are still try the use of the 28 gigahertz, but still in trial version. But this year or next year, we will release 28 gigahertz with SA and NSA. But the problem is the 28 gigahertz is too burden to cover all of the nation. I mean, in South Korea, we have to use the frequency efficiently. So we think 5G SA is for the B2B services, and also we think 3.5 gigahertz is enough to the B2C services. So we are focusing on B2B service for the 5G SA. And also, as Leila said, the network slicing, we also considering the network slicing, but in the case of the radio part, we call the RSI, radio radio slice indicator. So, but it's pretty hard to make the network slice in radio system. So we prefer use the different kind of band of the frequency, like 3.5 gigabit for the B2C and 28 gigahertz for B2B. So it's totally isolated frequency. It's far from between the 3.5 to the 28. So we use two kind of the band in commercialization of the 5G. So as the earlier the presenter said, we also want to co-work with the cloud computing provider. We said like AWS or MS Azure, and they want some kind of the co-location services with the telecommunication company. So they, like for example, AWS want to construct the infrastructure for the wavelengths in the telecommunication infrastructure. So like on this page, so we have 12 edge cloud data center in the South Korea, and all the 12 data center are related to the AWS and the MS Azure. So we are co-working with the cloud service provider, like you said, at the hyperscaler. And in that case, the most use cases is about the VR and AR and EMBB. It's based on the advantage of the bandwidth of the 5G. And we also want to enhance the security and want to give the low latency to the customer. So that means we, in some cases, like a smart factory and the smart offices, they need really ultra low latency. Yeah. So in the case of the URLLC, we think just 12 data center is not enough. So we think the use cases of the 5G that can be divided into the edge cloud and also edge on-site. So we divide the two type of the 5G edge computing system. So public cloud is based on the 12 data center in South Korea. As I said before, it's co-located with the wavelengths and MS Azure. And the on-site edge is specifically only for the B2B enterprise customer. So like a smart factory and some use cases can be the cloud robot and the CCTV. CCTV is required a lot of bandwidth, especially to the uploading to the server. So definitely need the 5G radio networks. So this kind of services we are focusing on to expand the business cases. So yeah, we as I said before, the collaboration with the public cloud can be in the case the telecommunication company can be the dummy just pipeline of the network. So we want to give some kind of the quality, the connection quality to the edge cloud customers, like QoS and adding the GBR and specific network slices only for the MEC or URLLC. But we still find out some more details because when we just use the slice only for the MEC, we cannot control all kinds of the applications for the MEC. So when we allocate the network slice for MEC, then after then, all the applications of the MEC should be controlled in the 5G infra. So that's why we want to develop some kind of MEC platform that's very similar with the hyperscaler. So we developed the same kind of concept, with the hyperscaler, and we use the port like a cloud portal, and also we support the scalability of the cloud capacity, like giving the CPU resources and the memory resources. So we have the 4 type of the edge computing, and the one thing is only for the B2B specific version, the small and medium business site. So it totally depends on the business site. So like a semiconductor factory, we use the 28 GHz that can be isolated, or we isolated from the B2C customer. So they can use isolated frequency and also use isolated radio RU and DU, and also we use we call the MEC platform that's local traffic local breakout, and also they gave some kind of host, CPU resources, and the memory and disk. So it's a kind of telecommunication company version of the kind we say that, for example, like Outpost. So we are the telecommunication company also now are supporting those kind of hyperscaler functions and the cloud functions in the 5G networks. It's not about the 3GPP standard, but we also want to give those kind of services in the 5G networks. So we are still researching and developing this kind of platform. And the larger scale site, we can put and insert the enterprise gateway. That means in 5G SA, it's a P gateway, the small version of the P gateway, and in 5G SA, that can be the UPF. So by using the UPF or P gateway, we can create a CDR in case of the traffic, but we also want to, as I said before, want to give the cloud resources and the CPU resources, and we also billing like the cloud plan, as AWS and MS gives to the customer. So almost, and third one is about the 12 data center. It's all the B2C customer can connected in the 100 kilometer in South Korea. And in normal cases, we just use the main 5G gateway that's in the 4 data center in the South Korea. Is the distance is in the 500 kilometer. So in the last one is about just a normal case, in LTE and 5G. So we have 3 different levels of the edge computing platform and services to the customer. So we are collaborating with the cloud service provider with same level, same structure, parallel with the cloud provider, like a public cloud console, like Azure console. We also support the physical portal that can be a console, right, to the customer. And also the AWS and MS Azure also support the public cloud infra. We also support the 𝗦𝘂𝗽𝗽𝐺 cloud infra by using the 𝗦𝘂𝗽𝗽 platform. So this kind of platform fits perfectly into the 5G network infra. So telco and cloud also sync the telecommunication company and the cloud company both are thinking the same way. So it can be the competitor or the core can be the collaboration. So now we are still struggling with cloud company. So in that case, we still have some kind of have to discuss about the edge policy issue. So at first, how to manage the edge cloud with CSP. So that means we are not just about using the MSP, multi-service provider, that's related to the CSP. We are the telco infra and host on the telco platform. So connect with the CSP like wavelengths and the MS Azure. The police server should be connected with each other. So share the information like on the cloud platform, we have to know about the information of the application and the service detailed to give the right SLA and to give the latest location information. So how to in second, how to manage the nearest edge cloud location for each customer. So we have distributed the computing resources. So for example, we have 12 data center and each customer's locations are different. So every customer must connect it to the nearest edge cloud data center. So how can we do that? So that's main kind of the issue with the CSP collaboration. And in that case, our 𝗦𝗃𝗍𝗃 platform must give the information about the service-related SLA to the CSP policy servers, and also CSP policy servers also give us the service-specific information. So nowadays, the cloud provider also now start syncing location management, like for example, Anthos also sync like location director, like effortless approach, like something like that. So they sync location policy is very important in case of the edge cloud. So they still we are still working with the location policy with the CSP. And the last one, the how to manage app and service aware policy before using network slicing and URSP. We all know about the network slicing is very useful and important, but network slicing is should be supported by the URSP. That URSP is in the capability of the device. So the device should support the URSP, and it's quite far from now. Yeah. So before 5G SA, we have to find out the controlling edge computing apps, how to divide the edge apps and just normal apps. So we still find out. I want to find out how to make the service-aware policy in the real telecommunication infra. Yeah, that's all. Thank you for thank for the listeners.
Thank you. Thank you for the brilliant, awesome presentation, Kongsan Ko. Moving on to the next speaker, let me introduce Faizan Khan from Geneva, Switzerland, to present on the 5G and IoT applications.
First of all, good morning or good afternoon, everyone, depending on wherever you are. And apologies for being late. For some reason, the invite wasn't in my agenda and there was a conflict, but I'm glad I'm here now. Maybe a brief introduction of myself. I'm Faizan Khan, based out of Geneva. I have more than 25 years of experience in telecommunications. I've worked with companies like Swisscom, Orange, Etisalat Group, Jersey Telecom, And I've lived also with these, working for these companies in different parts of the world. I've lived in Dubai, Jersey, India, UK, Switzerland, Canada. So that's sort of what I bring. But I suppose, unlike most of the other speakers I've heard the past two, my area of work focus has been on the commercial side. So sorry, for another apology, I don't have slides. I wasn't certain I need to prepare, so I'm going to just talk without having slides. So, and hopefully that will give you a flavor of what I want to share with you today. And then maybe at a later point in time, sometime, then I can have slides as well. But coming back to what I do, what I've done, my work has been mostly on the commercial side of things, on the international commercial side, international business of telecommunications, wholesale, carrier services, roaming. And the past few years, I've been heavily involved with IoT, especially with Jersey Telecom, Internet of Things. So I'm sort of going to talk more about that side of the business on IoT and on the commercial, let's say, opportunities and the challenges that we have. Look, 5G will bring a number of opportunities. I mean, that's something that has already been mentioned more than a few times. The opportunities are probably divided. They are as much in the IoT space, Internet of Things, M2M space, as they probably are on the consumer side of things for the need to have high band speeds for mobile data. But I believe that in reality, 5G's true worth would come out with IoT applications, with machine-to-machine business. And that already has been, even with 4G. And I want to sort of use the current context of 4G as a stepping stone into 5G. We already see IoT applications in 2G, 3G, and in 4G as well right now. There are the business of M2M is expected to be $1.1 billion by 2025, $1.52 billion by 2025. So really impressive growth. There are approximately more than 100 IoT devices, depending on who you read, which are being added every second. So by the end of 2025, we expect 25 billion IoT devices. And this growth is really, really exponential. That being said, the current progress, howsoever impressive that may be, is still at its infancy, I believe. What we really see in terms of applications primarily, I don't want to go to outline it primarily, are really basic stuff. Most of the time with things like meters, things like smart electricity, smart homes to a certain degree, or tracking devices. So not really the kind of applications that 5G would be known for in terms of either augmented reality or virtual reality or self-driving cars or doctors performing operations through 5G connected robots and so forth and so on. That is yet to happen. What we have seen already in the past few months is this gradual increase of bandwidth and low latency requirements in the IoT space. And there are some, but it's still small, where you see more than a few gigabytes of IoT used per device, data used per device, unlike the few megabytes that you would see a few months back. So this is changing, this is increasing, and already within 4G we see that evolution of providing these services happening. So we see things like local breakout. People are getting point of presence where probably a first step in edge where the service is being delivered. If the service is delivered in the US and the service provider comes out of Europe, he is looking for a local breakout option to provide the latency requirements that are being required by a particular IoT application. So that's where we are with IoT, but that is bound to grow. But there are still a number of challenges. I think what we tend to look at always is a very rosy green picture of things are going to be fantastic, which is going to happen. But there still are a lot of challenges that exist today as we speak, and they will continue to be for some time to come. But that is not to say that challenges do not mean opportunities, but they're still worthwhile taking note of. So I sort of divide those challenges into 2 or 3 categories. One is on the basic connectivity side, and the other one is on the technology side itself. And those are quite overlapping. And the third one, which is slightly more commercial, is on the cost, on the actual cost of the service, of the device, of the module. But coming back to the connectivity and the technology bit, look, a typical IoT application there's an IoT module, there's a casing which performs a certain kind of an application. There's a smart camera, for example. But a lot of these devices, they're manufactured in a central production locality, central production facility, and then they're distributed all over the world. And what this means is that typically this central production facility would already embed a SIM card with a particular service provider. So if it's a car being manufactured in Germany, one would imagine that it's 𝗘𝘃cie Telecom's SIM card for a connected smart card that is already being embedded and then being shipped to wherever else in the world. And mind you, a lot of the IoT applications that we see today are fixed. If there's a smart meter, gets put on a wall or somewhere, and it's not going to move from there. But it might have a SIM card which is coming from a different country, not from the country that the meter is based in. What this does is that it creates a few challenges. Some regulatory, legal, and some commercial. The legal and the regulatory challenges, and I talk about these challenges because they exist today, but these challenges would need to be resolved for 5G as well, because with more and more complicated applications, more and more requirement for sometimes the local governments to sort of, for use of a better word, interfere or be aware of, then these challenges need to be resolved now to be able to really make use of the 5G growth that we see. So the legal requirement is that if you have a device which is based in a country which is permanently roaming, there are legal regulatory requirements in a number of countries whereby the governments are saying, look, we need to know what is happening in our countries. We need to know what is happening in our jurisdiction, and we need to have full control of the communication setup. So effectively, what it means is that you need to have a local SIM card or a local SIM card identity when a device is permanently roaming in a country. Now that is easier said than done. As I said, typically production facilities are quite centralized, and then the devices, you can't put in multiple network SIM cards at the time of, or embed or program at the time of production, because that is just simply too complicated, too expensive, too cumbersome. So you don't have that happening today. And that's one challenge that is already there. You see that in countries like Brazil, in Turkey, and in a number of other jurisdictions as well, where governments, regulatory bodies have already indicated that they would want this to happen. The other challenge is actually more commercial. And that is because if you provide an IoT solution in a different country, there is a tendency to believe, at least in the short term, from the local service providers that someone from outside is coming in and cannibalizing their local market. As a result of which, they might put commercial obstacles to provide your service, because, let's be clear, you need a local telecom partner. You need a roaming partner to be able to provide that service for the IoT. And they would put either testing requirements which cannot be met, or commercial requirements which make the service more expensive. So those are the two things on the connectivity, on the globalization of IoT, which we would need for our current technology requirements, but which would need to be resolved for 5G as well. There are solutions in place, by the way. So it's not just all black and dark and gloomy. There are solutions in place. So we have things like eSIM, 𝗬𝗚CC. And the whole purpose of 𝗬𝗚CC and eSIM was to manage these kind of scenarios, amongst others. And basically what it means, and you see that happening somewhat in consumer devices. Apple has promoted that in a few countries, and less so on the IoT side. But what it really means is that if I have a device which has a SIM card from, let's say, Switzerland, and is going to be permanently based in, for example, Australia, just for the sake of discussion, then an 𝗬𝗚CC capability would allow the SIM identity or the 𝗬𝗚CC identity to be localized. So you would have a local service provider whose identity would be swapped with the Swiss identity. So someone like Telstra or Optus, that identity would be swapped in that particular IoT device. Now, again, that is easier said than done. It is complicated. It is still being trialed in spite of all the guidelines and specifications that we have from the likes of 3GPP and GSMA. it is still not really been properly democratized as such. So I give you a very simple example. Think of a tracking device in a truck, which is let's say in Europe, in France, and you put in a local French profile. What happens if the truck goes into an area where you don't have coverage for that particular French profile? Do you switch the profile again to a different operator's profile in France, or do you switch it back to the home country's profile, and how quickly? And if you switch it back to the home country's profile, once the network coverage is achieved again in France, you switch it back again. So, these are all practical things which really haven't been done and implemented. So, one might think that 𝗬𝗦𝗂𝗽𝗍 as a technology would resolve all these issues, but in practical real life, these are still things that need to be resolved. Just in the same way, you have new technologies dedicated for IoT, which will be used for 4G and which would be used in 5G as well, LPWAN technologies. You have things like LTE-M, you have things like NB-IoT. These technologies are just dedicated for the purpose of IoT. LTE-M uses LTE as a base technology, and the same for NB-IoT with some adaptations. And again, one would think that if the device is manufactured in Germany and goes out to any part of the world, you would see seamless access. Forget the 𝗬𝗦𝗂𝗽𝗍 bit, but you would see seamless access. That doesn't happen because guess what? In spite of all the details of how to test, what needs to be tested, testing really hasn't happened. You do see announcement from some big players, but I can assure you, being in the industry, that this is really at its very early stages. You have CAT-M devices roaming and using a particular network outside their home network, but all the features, power saving mode, enhanced DRX, all those things are still not being tested properly. Really just anecdotal evidence. So unless we really put what we have on paper and theory in practice, the IoT dream that is going to drive at least 50% of the 5G value, if not more, would probably be a bit of a distance still, because we need to resolve all these kind of issues. And like I said, the commercial aspect also needs to be resolved because the charging models have completely changed. In a typical scenario, you would just pay for use, but for IoT, people want to charge for the value, which makes it more expensive, which is a fair way also, but it just makes it more expensive. The reason why I'm saying all of this, because number one, not only is it relevant not just to 4G, but to 5G as well, but we have to resolve all these issues in a global way for 5G as well. We talk about network slicing for 5G, but no one at this point in time is not really clear what kind of testing we need to do, or how would we bill each other, what kind of network slicing requirements would be there, how do I buy a network slice, will we exchange billing records as we do today? And all those questions still need to be done, need to be resolved. My point is not to sort of, like I said, it's not a doomsday thing. It's not to paint a negative picture. It's just to highlight that these are still issues that we face today, and they would need to be resolved because we are talking about 5G. I give you an example. We still have 2G, 3G networks globally. There is sunset happening for 2G, 3G networks in many parts of the world, but we still have 2G, 3G. And 4G networks are there in plenty, and 5G have yet to sort of take off. Voice is a very basic service. Now, whether you use voice as a as a voice service in 2G or 3G as a circuit switch service, or you use voice over a data over LTE in a 4G scenario, but people will still continue to use voice. Just I would want to sort of just call someone. I know I can use it with OTT, with WhatsApp and everything else. But there would be requirements either by businesses or by individual customers. They would just call make a voice call, and that will go over data, over LTE, and you would think that would be seamless. Today, there are very, very few networks which have implemented VoLTE, voice over LTE, in a roaming situation, because no one knows how to test. Even nationally, that is very limited. What this means is that if we haven't been able to resolve this today for VoLTE, for LTE, we need to be aware that this is going to be something we need to resolve. So theory aside, we still need to sort of get those things in order. The other important element that I've encountered as part of my commercial discussions, and that's something that I believe will happen seamlessly as time would pass, is the cost of a 5G module or a 5G device. 4G was still considered, one of the reasons why 2G and 3G IoT devices carried on for quite some time is because 4G, and especially with LTE-M and NB-IoT, they were quite expensive. But in the past few months, they have come down significantly, as a result of which pretty much all the new applications that we see are 𝗰𝗂𝐶 compliant. Sorry, all the new modules, hardware that we see is 𝗰𝗂𝐶 compliant, is 4G ready, is NB-IoT and Cat-M1 already installed, or already part of the module. So that is happening, but that's something also that we'll see as progression for IoT, because initially, obviously, as any new technology, it will be expensive. The module will be expensive. And I think there was a belief that, for example, for 4G, we would get very quickly onto the 4G devices, but it's taken us some time. So I'm just sort of making everyone aware that is also one thing to consider purely on the commercial side. Those are the few things that I sort of wanted to share with you. That being said, once again, the forecast, the numbers all seem to suggest that, look, in spite of the challenges, no one can deny that these are opportunities. The only point is that technically, yes, we need to do what we need to do, but commercially also, or in real life situation, translating the technology that we know on paper into a real life situation still takes time, as we have seen. And that's just something I want to sort of make everyone aware of and share here. I would be happy to take questions if there are any.
Thank you so much, Faizan, very well articulated. We have another one speaker to go, and I really hope, Faizan, if you can spare us for some time during the Q&A, because there's one interesting question that I would like to address during the Q&A at the end of the session. So thank you so much. Moving on to the last speaker, Alessandro Puglia from Milan, Italy. Welcome, Alessandro.
Hi, everyone.
On the 5G for Industrial District.
Yes. Can you see my desktop? My presentation?
Yes. Yeah.
Okay, perfect. So thank you very much for your invitation, and thank you very much to all the people that are joining this roundtable. So I wanted to start with a quote about 5G, because from Eisenhower, plans are useless, but planning is essential. Currently, 5G is still a plan, because there are a lot of POC around. We see a lot of experimentation, etc. But still, it's very complicated for a telco to plan really what is the 5G society. I would like to change a little bit the paradigm from 5G as a network, from 5G as a booster for the 5G society. And currently, there is a big difference between the path that we plan and the reality that we are living. So, if we take all the analysts from the market, we know that the 5G will have a very huge impact on the economy in general. Just in Italy, we thought that the output by 2035 would be more or less 45 billion, and an increase of a job of 250,000 of new jobs created by the 5G implementation. This is not related to telco. This is related to all the digital services that will be enabled by the 5G deployment. And as you can see in this picture, there will be a huge impact on manufacturing, on the retail, on the logistics, etc. As we saw also in the previous intervention, there is a huge focus on what is a private network, on the slicing, on how to make real use cases that need low latency and a huge bandwidth consumption. And in the previous also intervention, there was an important discussion about how IoT will have a a lot of benefits in the implementation of 5G. Is a free will. 5G is a free will, is an enabler of these new other technologies. But in the manufacturing in particular, we see that the digital transformation is already ongoing. The digital transformation can be already done with private LTE, can be already done with Wi-Fi 6. There are a lot of use cases that we discuss inside of 5G that can be already done with existing technology. So what is the differentiation in 5G? For sure, we can think about what is 5G native, like real-time control to adjust the process in motion, full automation, connected factory, the use of fiber wireless access for improving the connectivity, the collaborative robots, or also remote operation like we saw in the mining example that before was explained. But there are a lot of things that can be already done now. And if we see a attack matrix that is on below on right, we should analyze where is the 5G impact in reality and where is also the digital maturity itself. Why that? Because when a manufacturer will move on the digital maturity level, they will have more and more object connect. They will have more and more use cases that will be on the same infrastructure, and this can be a problem. So, meaning the digital roadmap should be associated with a connectivity strategy in order to understand if the current infrastructure where you see the same use cases, virtual training via AR, VR, real-time machine capacity planning, etc., predictive maintenance, etc., if they can still live on the same infrastructure, you need to think on multiple connectivity layer, or you need to move to a convergent technology like infrastructure technology like 5G that can really support multiple use cases at the same time. But here, there is also a big issue, because if we think about a private network, 5G private network, where the business case consider not only the implementation of a dedicated edge in terms of ET and the network, but there is also dedicated operation. There is a huge effort in managing everything that will go on this 5G private network. If I see the Italian case, 95% of manufacturers here are small, medium business or micro business. So company with less than 1 billion of revenue per year. You can see here a slide that is summarizing region by region how many districts we have, because these small, medium companies, they are partnering all together in same areas in order to create a chain, industrial chain, supporting each other. So the real question here is, how we should think to implement the 5G in our country in order to have also a positive business case, a positive impact, and accelerate the 5G digital society. And the answer can be, and this is something that the telcos, consulting, and network provider are already thinking to do, is to create 5G district networks that will serve the same district with one single shared infrastructure. And at the same time, the telco can also think to provide as a service, in a managed service, the infrastructure, but also the platform that will go on top of this infrastructure. And here there is a big change in business model of the telco that I think is more than 10 years since the first over-the-top arrive in the market, are trying to not be commoditized. and still have a good position in the value chain in order to be profitable. And what can be this new business model? Telco they are making this long journey of becoming a digital telco, and now they are claiming to transform again from a digital telco to a digital techco, so a technology company, in order to enable, in particular for the 5G, a paradigm that is the 5G2B. So a platform that is not only giving connectivity and cloud infrastructure. They are exposing internal business operational support systems. So someone before in this roundtable talked about network as a platform also. Through API expose network functionality to third party that can be a final customer as well as a digital service provider. Create an ecosystem that will enable 5G digital service creation, so a marketplace that will become really the differentiation from one telco to another telco, marketplace that has to be enhanced by onboarding functionality, artificial intelligence, multi-site IoT, to have several use cases on top of the same platform, natively integrate with the connectivity and cloud infrastructure layer, as well as have security by design, implementing digital identity, device entitlement, device SIM management, eSIM management, and expose this marketplace to internal function that want to create their own digital service, as well to third-party DSP and IoT provider, in order to give to a district one single stop to have all the functionalities that they need to accelerate their digital transformation and become smart factories. From cloud ERP, from IoT, connectivity, etc. And this is my last slide. This is a journey that foresee a visioning to create a 5G factory in order to experiment all these use cases to be put on the marketplace together with an ecosystem of partner of institution, clients, network provider, IT company, etc. Generate connectivity roadmap approach so that every smart factory know what kind of connectivity now and in the future they need, and then understand what are the key business operating process transformation need to be applied to benefit the 5G transformation and the smart factory. I don't know, Ganesh, if I am on time or I have other few minutes.
You have another 2 minutes.
Okay, perfect, thank you. So, and this is a huge thing. It's a huge thing because the connectivity roadmap is not only associated to how much bandwidth I will need in the future, or what is the change in latency requirement that I will have. It's also associated to a make or buy strategy for the sensors, because not every sensor currently, IoT sensor or machinery, are already 5G ready. So I need to understand inside my connectivity strategy if really I can move to 5G for my AGV, for my connected machinery, etc. What the regulation will allow or not. With some customer was discussing about AGV in external environment for logistic purpose. In Italy, the regulation will not allow AGV that have not control with line of sight. So purely self-driving AGV for external. In internal warehousing is possible, in external not. So all these things need to be considered, analyzed in order to create this important 5G2B digital platform that will enable really the manufacturers, and now that we are talking about post-COVID and recovery from post-COVID is quite important, will enable these micro enterprises, small medium business, to recover from the pandemic and accelerate in digital transformation, reposition themselves on the market, considering how much they can be innovative in products and in their operation. Thank you.
Thank you, Alessandro. Excellent. Thank you. I appreciate that. So let's have a 10 minutes Q&A session. If anyone have any questions to be addressed to any of the speakers, please feel free to question. Maybe I can able to start first. Now let's discuss what is the most really appealing happening in the world here, right? Like for example, COVID-19 is a highly contagious disease resulting from an infection with like SARS, CoV-2, a type of coronavirus, and that can mutate, forming new variants. Like some of these viral variants may spread more easily or lead to more severe illnesses, right? So like in May, for the second successive week, the number of COVID-19 cases globally remains as the highest level since the beginning of the pandemic, with over 5.7 million newly weekly cases, following 9 consecutive weeks of increases. So new deaths continue to increase for the 7th consecutive week, with over 93,000 deaths per week, right? So that is like huge. And the Southeast Asia region continues to report marked increase of both cases, death incidents. India accounts for over 90% of both cases and deaths in the region, as well as 46% of global cases and 25% of global deaths reported in the past week. Right, so it is important for scientists to continue monitoring new variants and their characteristics. Emerging variants may be able to spread more quickly, cause more severe disease, avoid detection, routine testing. So my question is here: with 5G and technology and IoT, the AI, whatever that we have, right, machine learning and all that stuff, how on a large scale, how can we able to address or working together, maybe with WHO or any of the large telco mobile operators who are internationally based, how we can able to solve this kind of pandemic issues, right? Of course, we can't able to address or stop these pandemics, but how can we able to be more prepared? Maybe in either it can be a people tracking, people tracing, or it can be a mobile clinics, or it can be a proper contingency measure plans. Or the results of sample testing, how we can cut down the measures. So in your opinion, what do you think the best way we can use technology to address these pandemic challenges? Anyone would like to take that?
I think contact tracing is one of the areas where technology is really applicable, and it is being enabled to a large extent in most phone providers here in the US. And I think I see that there is an option provided at least by AT&T and a few others, whereby you can enable such features for contact tracing. Privacy issues aside, I think there are certain challenges with respect to privacy, of course, that many people are concerned about as to how their data will be handled, which kind of limits the reach of the technology itself. But other than that, I think we've seen that contact tracing solutions by which you can monitor data about users and which other people they came in contact with has helped. And I think China set a good example of it right up front, with so many applications that they had, that they were able to kind of make containment zones basis those applications. So I feel that's one of the ways that we can potentially use technology for contact tracing in this COVID world.
Anyone else would like to?
I think the other evolution that is happening generally is travel will become more difficult by definition, or more restrictive, or there'll be more checks, and when there are more checks, then it becomes more hassle. The travel process itself becomes more hassle, because in any case people are queuing up for their bags and sometimes for visas, depending on what passport you hold. But if everyone has to be checked for COVID as well, then once travel comes back in full force, that will be that will become a major block at airports, and especially in Europe, where we tend to travel quite quickly for business. Sometimes day trips. If business travels will face that will become a major challenge for them. A lot of the governments and companies like 𝗦𝘂𝗽𝗽𝗃𝗃, which are in this business, have actually started working on the COVID passport. So when you get a COVID vaccination done, you can have it, put in this app, which is predominantly done over blockchain to ensure the authenticity of the information that is there. And countries and governments and airports and airlines are coming together to ensure that this information is available to different stakeholders in the travel business. And by definition, the 5G and telecom industry will play a role in that. In fact, the discussion that is happening is how can we make the entire process of travel seamless, so that I know when my bags are coming, and that will be implemented or enabled via IoT. So I don't have to sort of rush to the bag belt till I know what the status is. I can take it easy, and then I can sort of seamlessly walk in and out of the airport, because my phone or will allow that information to be processed seamlessly as an individual and as a corona tested individual, that these hurdles move away. So 5G will play a major role in making the travel process more smooth. I'll just give you a very simple example but today already we have this touchless or contactless check-in procedures. You scan or access through an app, you show your passport, but you might not even have to do that, and it will become even more seamless, more quick, more prompt. And that is what the different travel stakeholders are working with telecom providers and solution providers, like I said, 𝗦𝘂𝗽𝗃𝗃 and others. So I think that's one interesting evolution that we'll see, and that is already happening somewhat. But I've been told that in Europe, many countries are in the process of adopting it. If they haven't adopted, I actually know also in Africa they've adopted the COVID passport through a particular application. So this is something that we'll start seeing happening in the near future.
Yeah, just taking a cue from what Faizan just said, I think both on the retail side and hospitality side, I think we are seeing more of these self-serving kiosks, which allow for authentication as well as authorization in many ways in a contactless fashion without any human intervention in many cases. Marriott recently launched a self-serving kiosk at one of its properties, a chain of properties, I would say, within their group. So that's coming up, and a lot of retailers in the US are experimenting with self-serving and self-service checkouts in large numbers, and they are being implemented for the last 1.5 years with great success. So in many ways, these technologies are getting enabled, which would kind of help fight COVID infections in many ways.
Thank you so much. Any other questions from any of the speakers you want to address to any other speakers? Please feel free.
I had a question for Mr. Ko from SKT. I wanted to kind of get a feeler from you on your experience working with AWS. So has it mostly been cordial, or are there tensions in certain ways that come up during your conversations? AWS Wavelength, I know you've kind of deployed it and you're using it, and you must be interacting with AWS folks. How has your experience been like there?
Yeah, the AWS is pretty kind of they work with the large of the telecommunication company. So in South Korea, the AWS is much has much power than the telecommunication company. So they usually think pressures the policies in their view. Yeah. So when we make a commercial agreement with the AWS, it's pretty hard, really hard to negotiate the conditions to co-work with AWS, and especially in the part of the security part, because the wavelengths really, the AWS has a really strong concept of the in the case of the security. So we have to protect these things, and we have to hire the security guard, or there are lots of security policies are required. So that's main kind of conflict with the AWS, and the problem is the main problem is that the public cloud provider, they really just want to use the want to make a business cases like a co-location business. So it's just they just want to install their wavelengths rack into the telco infra, but we don't want to. So yeah, they think we the telecommunication company just support the connectivity to the public edge cloud, but we want to expand the industry to the of course to the edge cloud. So that points are conflicting with the large CSP company. So in this kind of conflict is also happens when we negotiate with the Azure. Yeah, it's almost the same process with the other cloud provider.
Makes sense. Thank you.
I have a question to 𝗂𝘃 as well. You have mentioned the for the 28 gigahertz, you are actually covering for B2B, and I believe this B2B definitely is for like industrial enterprises, and as we know that 28 gigahertz is more appropriate for indoor services. So how do you tackle 28 gigahertz for outdoor when it comes to the B2B industrial? Do you have any issues?
In case of the 28 gigahertz?
Yes.
Yeah. So it's almost impossible to use the 28 gigahertz for the nationwide, because as you said, when we install the 28 gigahertz by using the RF, we at least 10 times more RF to be installed comparing with the 3.5 gigahertz.
Right.
So it's much expensive than we expected. We calculate the cost is at least 10 to 12 times much larger than 3.5 gigahertz. So we use only for the big enterprise B2B customer when we use the 28 gigahertz, because it's totally isolated, and like in South Korea we used that with Samsung. Yeah, so those kind of big company, that I mean the large enterprise is in South Korea, just 20 or 30 companies in South Korea. So we just support some specific large enterprise B2B customers.
Thank you.
Guys, I'll have to move on to my next call.
All right.
But just want to thank everyone. Thank you, 𝗃𝘃cie for organizing this. It's really nice hearing the few speakers that I could, and I'm glad that I got to know you somewhat briefly, but still got to know you. Thanks very much, guys.
Thank you.
Thank you very much.
Thank you.
Thank you.
Right. So any other speakers have any other questions to address? By the way, Lawrence, what type of a frequency that's being used for the hydraulic remote control trucks?
At the moment, for the autonomous haulage trucks, we use band 1 in Australia, which is it's on 2100 megahertz. So that's the one that we are using for our system. So we have a private LTE network, and we only managed to get 5 megahertz because that's the other challenge with private LTE networks at the moment. Getting spectrum is really difficult. So for our deployment, we just managed to get 5 megahertz on band 1, and that's what we're using.
Right.
Yeah.
Okay. Any other questions? If not, I would like to thank to all the speakers. I really appreciate for your time and your effort. It was a brilliant presentation done by all of you. I really appreciate. I'm so grateful for your time and effort. And we will upload this video very soon, within a couple of hours on our YouTube channel. And please do have a look, and please do share this to your family and friends. And thank you so much. And please have this networking of all the speakers, as I have shared this email of all of you. And please feel free to get connected to each other via the LinkedIn. You never know where our journey are heading to. So it's good to know all of you. Thank you so much. I appreciate that.
Thanks,
Thank you very much.
Thank you.
Thank you.
Take care. Bye-bye.
Thank you. Bye.